Okay, so we're going to go ahead and take a look at the segment addition postulate. I noticed in class I had a few people look at these kind of problems and they immediately wanted to raise their hands because they weren't sure what to do because the problem doesn't explicitly tell you step by step what to do, but it does lay out the problems pretty thoroughly. So let's take a look at what this segment addition postulate says. So I'm going to turn on my document camera and bring up something that I have right here prepared for you. So the first thing is what does the segment addition postulate say? Well, the segment addition postulate says if you have a segment with A, B, and C that are collinear, notice that means they're going to be on a line segment together. So we're going to go like this, and it says with B in between A and C. So here's A and C. Now it's specifically that we put B right there in the middle somewhere. Now, it doesn't have to be perfectly in the middle, but it's in there somewhere. Then what this means, and you got to watch the font on all this stuff, the way that we write stuff. When I say AB, that's looking at a number. And so it would say that the number that represents the length of AB plus the number that represents the length of BC would be the same as the length of AC. Well, again, that might not seem obvious to everybody as we look at it, but if you think about it, that's saying something like, let's suppose that this part was 7 and this part was 5, then you could say that 7 plus 5 equals 12. Something along those lines. We're literally saying that this is going to be some value that I got when I measured it. So let's take a look at two questions. Now, these are not actually questions that are directly off of your homework. They're ones that I made up this morning when I kind of prepared for this. So let's read what it says. 1 second here. We've got our little video going, but it's all right. So our little stuff. Now it says given segment DF. Now I can either name it segment DF or I could just put it this way, and that is also a way of saying segment DF. So here we go. And it says that E is between D and F. There we go. So the first thing that I'm going to do is I'm going to draw a picture of the information that they handed me. Now they told me that the length of DF is 27. That means this entire length, all the way across, is going to be the number 27. Now it says DE, this part of the length is 7 minus x and 2x plus 22. Well, now we can actually use what this segment addition postulate says. Sorry, now that noise is gone. Is we're going to take the first part plus the second part, and we are going to set it equal to the entire length. That's the left side plus the right side equals the whole thing. Now, this is turned into a very simple algebra story. We want to combine our like terms. So we would notice pretty quickly that right here, this negative x and this positive 2x would be considered like terms. So we would have 1x because 2x minus x. We could also consider the 7 here and the 22 over here as also like terms. We're just kind of simplifying things a little bit. So that's x plus 29 equals 27. Now, of course, I want to keep going because it says, let's find the value of x. So I think I'm going to subtract 29 from both sides. And I found that x is -2. Now, in an algebra class, we're usually done when we found x because what else is there to find? You're always finding that unknown. But in geometry, we often go one step further because if you read the question, it says find the value of x and the length of EF. In other words, I just want to know this portion right here. So if I were to plug it back in, then 2 times x plus 22, but I just found out that x is -2. So I have -4 plus 22, that means the length EF equals 18. Now, you'll notice in this particular problem, I never asked to find DE, but I would tell you if I was taking a test in a geometry class, I'd find it anyway, and I'll show you why. If we plug in -2 for x, a double negative makes a positive. So I found that DE is 9. Now, what that did for me is it helped me check my answer because if this is 9 and that side is 18, then 9 plus 18 is in fact the length 27 that we said that it was. Now, when I designed this problem, I did something on purpose because distances must always be positive. So when we got this answer x equals -2, some of you might have felt uncomfortable because distances can't be negative, but x is the variable. And when we plugged it back in, we got two positive distances. So that's okay. All right, number 2. This is based on a problem that I honestly missed in class because I didn't read the problem carefully enough. Because we lay this problem out just like we did on the other one, but sometimes we actually ask the question a little bit different. And this is actually asking, is it the midpoint? Let me put a question mark. Is it the midpoint? So it's not saying find x, but of course I'm going to have to solve something to justify whether or not, in fact, it is a midpoint. So here we go. So we've got a, b, and c that are collinear, and b is between a and c. Now, when we say between, it doesn't have to be perfectly in the middle. It wasn't in the last problem. So let's see what happens. It tells me that AB is 3x minus 1. BC is 2x plus 7. And interestingly enough, on this one, it says that A all the way to C is 9x minus 26. We haven't actually done a problem like this in class. I decided I'd push it a little bit further here. So according to my segment addition postulate, if I took the left side plus the right side, and I set it equal to the whole thing, I can now set up my algebra. And just like the previous problem, I'm going to start by combining my like terms over here on the left side and get 5x plus 6, right? 3x plus 2x is 5x. 7 take away 1 is 6. Now we'll go ahead and keep moving a little bit. Let's subtract 5x from both sides. And I know that some of you guys won't want to show that particular step. You just want to come straight on down. And I'm actually okay with that. We'll add 26 to both sides. So 26 plus 6 is 32. And we can very quickly see that if we divide both sides by 4, I got x is 8. Now, again, in an algebra class, we'd be done, but that's not what we're supposed to be doing here in a geometry class. It's answering the question, did I actually find a midpoint? So if we were to plug it back into the original, let's go right here. What is 3 times 8 minus 1? And I got the number 24 minus 1, which is 23. So it seems that the length of AB has to be 23. So if it's a midpoint, I guess the other side would have to be 23 as well. So I would say 2 times 8, which is 16, and 16 plus 7 is also 23. So what I can determine is, yes, in fact, C is the midpoint. The midpoint. And I would say that since AB, remember, AB is literally the length from A to B, which we just found to be 23, is equal to BC. So I've justified why I know that's in fact the midpoint. Okay, we'll see you again for another video at some other time. Bye-bye.